Advanced Algebra with financial applications. Our learning target today is I can determine the break-even prices and amounts using technology or algebra. So you want to get your learning target up on there. Now, a lot of you probably already have this, so no big thing. You started it yesterday. We're finishing up today. If you are new here for today, for the missed a day or two, then we're picking it up. We'll have to catch you up because we did not do this front. We did not do this on the, at least in my class. We didn't do this original problem down here. All right. Yes. All right. So most of you already have the vocabulary. If you don't, if a lot of people don't have the vocabulary, we can pause the video right now and get that done together. I'm not going to do that here because we already did it. So maybe you want to talk to your neighbors, find somebody, talk it out. Don't copy, learn. Pause it here if you need. All right, if you paused, and now we need to figure this one out. Now you got to write kind of small here. I didn't leave a lot of space, unfortunately. It's kind of a big problem. It says, determine the prices at the break-even points for Rick and Betsy's microwavable coffee-to-go cup called Culk Cuppa Coffee. The expense function is the E of P. That's how you read that. The E of P equals negative 1,000 times P plus 10,000. What this expense is, remember, expenses are what the business has to pay out. This is the money going out. They have to pay money to make stuff. So like this $10,000 might be the machine that makes the thing, plus the insurance and the labor and the rent and all that kind of stuff. These are the fixed costs. This is how much, this negative 1,000 is how much it's costing them, or no, actually, it's in terms of P here, it's in terms of price. So this is how much less they're making for every dollar that they increase in the price. Then we have a revenue, all right? Revenue is the price times the demand. So the price they're selling their product for times how many people are going to be buying these things or how many people want this. So if revenue is price times demand, we can look at revenue as P times Q. And so the R of P, the R function of P for price is P times negative 1,000 plus 8,500, right? Because we had the, let's see, right? We had the E of P up here. So we're placing the E of P inside our thing. So I think actually I think I should have a typo here. I think what I'm saying is that the E of Q is here. That's all right. We'll deal with that. And we're just substituting this function in for Q here. So it's P times Q. We know that Q is going to be this thing here. So we're putting that in, P times Q in terms of price. And so now we're going to get a revenue in terms of price, which is 1P times negative 1,000P. Well, 1 times negative 1,000 is negative 1,000. And P times P is P squared. 1 times 8,500 is going to be 8,500 because there's a P there. We need a P there. And it says the break-even points occur when revenue equals expense, when your revenue function equals your expense function. All right, so determine the revenue expense at the break-even points. So here is how we do this. If our break-even points, and that's what we're looking for, we're determining the break-even points in our question, then we need to do revenue equals expense. Well, there's our revenue right here, right? So negative 1,000 P squared plus 8,500. When you want to write real small, because we're going to have a lot of space here, equals the expense function. The expense function was over here in terms of price. Negative 1,000 times P plus 10,000. All right, so that's our setup. Our revenue function is equal to our expense function. I just got to make sure this thing is working here. And we are recording. Good. All right, so I need to get everything on one side. This is going to end up being a quadratic, and to solve a well, okay, just back up. What is a quadratic? A quadratic is a function that has a U shape. All right, so let me just back up the idea of what a quadratic is. All right, a quadratic is going to have a shape like this, or also a quadratic can have a shape like this, right? And when we solve a quadratic, what we're trying to find is what's called the roots. the point at which the quadratic meets this horizontal x-axis. So like the roots of this quadratic are there, and the roots of this quadratic are right there. So when we're trying to, a lot of quadratics are going to have two roots or two solutions, two different numbers that make them true. All right, so this is a quadratic. Once I saw see p squared, I knew this was going to be a quadratic. And the reason why is because if you have any f of x, where x is squared, and you can give yourself a little table. If that's the x value and that's the y value, if x is 1, 1 squared is 1 times 1, which is 1. If x is 2, 2 squared is 2 to the second power, which is 4. If x is 3, it'd be x to the second power, which is 3 to the second power is 9. And if I start going back the other direction, I wish I'd put this in the beginning, but if I had x is 0, 0 times 0 is going to be 0. X is negative 1. Well, negative 1 times negative 1 is 1 again, just like we got over here. And then negative 2 times negative 2 is positive 4. So just like we had with 2. So you're going to see that if we start graphing these points, right, 1, 1 might be here, 2, 4 might be here, 3, 9 might be here, 0, 0 is going to be here, negative 1, 1 might be here, and negative 2, 4 would be here, and you're starting to see how that creates this U shape because of the squared function. All right, so this tells me I have a U shape, p squared. So I know it's a quadratic. That means to solve it, I need to find the roots, and that means I'm either going to factor, and this problem's going to be too hard to factor, likely, so I'm going to use the quadratic formula, which we learned last time, which I'll show you here today. All right, so I need to get all the numbers going this way. I could move them all that way too. It's just a decision you have to make with where you want to move it. I'm just going to move it all this way because I already have that there. All right, to move this 1000p to the other side, I'm going to have to do the opposite of subtracting 1000p. Hopefully by now you're all saying, oh, it's plus 1000p, right? I've got to cancel these two things out. Matter versus antimatter cancels out, right? That means I have to do 1000p over here, and I want to make sure I made an error. This is a transcription error. Does anyone see the transcription error that I have right here? Note this. I'm missing my p. All right, there we go. Now that I've fixed that little transcription error, I have to add 1000p here. Also, I'm just going to do this all in one step, save myself some room. I'm going to subtract 10,000 right now. Matter versus antimatter, need to cancel it out, need to move it over here. To cancel it out to get 0, I'm going to subtract 10,000 to get rid of adding 10,000. Goodbye. Now I got to do the same thing over here. Now, I don't know where to add it. I don't want to put it right underneath there. That might confuse me. So I'm going to put it over here for now. All right, let me rewrite what I have now. I'm going to do some switcheroos because I want this term to be in front. I'd like to keep things in standard form. So this stays, right? I still have this. Negative 1,000 p squared. I now need to calculate this. I don't have a calculator handy, so I'm going to grab my handy math machine. Could I do it in my head? Probably. But I want you all to do this on your math machine. I want you to save your computational brain power for the hard stuff, which is the reasoning and thinking. You don't need to take too much time thinking about all this computation. All right, 9,500. All right, 9,500, and they both have p's. That's I attach a p there, and then this is where I'm going to take my negative 10,000 and put it right there, or I'm going to plus negative 10,000. I like to keep things addition. You don't have to do that. That's just my personal preference to deal with negatives with addition rather than subtraction signs. I like addition because it means I can move things all around however I want. With subtraction, I got to be careful where the sign goes. All right, so now I have a quadratic formula. It is tough. I'm not going to lie. It is tough. The more you do it, the easier it gets. We have three terms. We have A, B, and C. I can show you what those terms are. Maybe the sign is actually better right here. All right, this is your A term. Your A term is attached to your variable that's getting squared. Your B term is your middle term. It'll have just one variable next to it. And your C term is your constant. I didn't make this up. I didn't invent this. It's just A, B, and C. All right? I like that C means constant, but I don't know how they got A and B. I guess they just figured it makes sense. Anyway, So my A term, I'm just putting the coefficients in. So negative 1,000. My B term is 9,500. And the C term is negative 10,000. All right. I recommend you do this. This will help you, especially as you begin, because this dang formula is kind of a little bit off. Um, I gave you the formula. If you want to go to your notes from the previous lesson, we gave you this formula. Now you're expected to kind of have this, well, once upon a time, students were expected to have this memorized. I know, right? Crazy. Memorized in your head. Um, and the Regents Reference Bank should have this formula there in case you forget what it was. So, okay, I've got to go take this formula and I've got to put it in. So I thought I want to keep, I'm going to take this later. I want to keep this in front of us. I don't want to spend up valuable paper space writing this formula for you. So to keep it visible here. So I'm going to this formula, and you see how my B value is going to go in for B. And every time I see B, I'm going to put the B value in. Every time I see A, I'm going to put the A value in. Every time I see C, I'll put the C value in. You ready for this? All right. Don't be scared. You can do this. All right. Students for 100 years have been doing this. Maybe not quite 100. Maybe 80 or 90. All right. Here we go. I'm going to start with the negative. All right. Negative. And this is how I want you to write it because this is how it's going to go in your calculator. Negative 9,500. Now I want you to put those parentheses in there. It doesn't matter this time because our B is positive. But when your B is not positive, it can matter. So we're just going to use the parentheses because if we put the parentheses when we write it, that's what we'll do on our calculator, and that will train you to do it the right way. Now, technically, it's plus or minus. When I put it in my calculator, I'm just going to put plus. And then I'll do another one, which is minus. That's why there's two different answers. There's one where I plus, there's one where I minus. This is what makes sense when we start throwing the calculator, but I hope, for you, and I didn't leave some space. Oh no. Okay, I need to be very careful with my space now. It's B. Okay, so I did this without even thinking. I have my negative B. There's my negative B. There's my plus and minus. So there's my plus. There's my minus, right? I'm going to have to do this two times, and the calculator makes it easy. There's a square root function, right? Square root function. And I need B squared. And again, I'm putting it in parentheses. I need to be so careful about my spacing here because I'm going to run out of space. Squared. All right, maybe I need to zoom in even more for you. Minus, I recommend putting parentheses here. And it's going to be 4 times A. I've run out of space. There's just no way. No tiny amount of writing is going to make this work. 4 times negative 1,000 times, I just have to remember this, 10, negative 10,000. So I'm going to multiply 4 times negative 1,000 times negative 10,000. Just have to remember that. And it all gets divided by 2 times A, 2 times A, which is negative 1,000 again. Here's what this looks like on your calculator. All right, here goes. First, I'm going to start with my fraction. To get that fraction, you need to press the alpha button and the number next to it, right? The alpha x. Alpha x gives me this fraction. And I'm going to put negative 9,500 in there, right? Like so. I'm just going to put the plus sign the first time. First time I'm going to put the plus sign. Then I need the square root piece. Now, maybe you don't know what square root is. It's in blue right here. There's the square root. And because it's in blue, that means you know you need to press the blue button first before you get there. All right, so second, square root. Give me that square root business that I'm looking for. And then now I need 9,500. Almost did a transcription error right there. Typing the wrong thing in. Squared. I need to square it. There's two ways to square it. You can raise the roof with the caret button and put a 2 in there, but that means you'll need to use the arrow key to get back down out of it. Or you just press this button right here, this x2 squared button will put that 2 in the corner and drop it down for you. So when it's just to the second power, that x to the second power button comes in real handy. Now I'm going to minus, and I recommend putting in parentheses here. I know Mr. Robinson doesn't do it this way. It's just the way I like to do it because it keeps everything nice and neat for me. Times negative 1,000. And I ran out of space on mine, remember? But I have to remember there's also a times a C, which is negative 10,000. Close the parentheses. That is my top. And now down at the bottom, I got 2 times negative 1,000. All right, I'm going to leave this on the screen just for a second. You can pause if need be. I'm about to press enter, and get an answer. Right? All right. Okay. So here's what this means. What am I finding? I'm finding my variables in terms of p, right? P is price. Oh, P is price. That's what P represents. So what this first answer is telling me that there is a quadratic such that one of its roots is $1.20. Well, we throw on the 21 cents, right? So our first root x can be equal to $1.21. In fact, I need my little squigglies because I rounded that. All right, a dollar 21, which is saying that one of the break-even prices that I have a quadratic, I have a expense function and a revenue function. Expense function is the straight line. The revenue function is this quadratic, and one of the break-even prices is $1.20. At $1.20, my revenue will equal my expenses, which means I'm making no money. All right, here's where the calculator is super handy, and it's just wonderful. Press the up arrow key. Press the up arrow key. You can't see it when I do it. The up arrow key right here. Boop, boop. I want to highlight this and then press enter. I get the exact same thing copied in. And now I want this exact same equation, but with one little change. I want to change this positive or plus to a subtraction sign. Not a negative, but a subtraction sign. All right? And this will now do this piece where I'm minusing, right, rather than plus. You're going to do this quadratic equation two different ways, one with a plus there, one with a minus there. It's plus minus. Every quadratic has two potential roots. I press enter now. Oh, okay, I already gave you the answer. Normally, if I was in class and I was thinking harder, I wouldn't have given you this. I would have made you figure it out. Maybe I need to edit this to make sure you do it yourself. $8.29. Yes, I like that. So now I know there are two prices at which there are break-even prices. There's one, if they sell this cup of coffee or this product for $1.21, they will make zero money. They will lose zero money. If they sell this thing for $8.29, they will make zero money. They will lose zero money. And the reason why is because those are the two break-even points. Those are the 2 points at which where revenue equals costs. Now, every price in between there is a profit-making situation. This is why this math is so valuable. You've just been taught how to tell a business what prices their product needs to be to make a profit. In fact, you'll eventually figure out how to show maximum profit. Like the maximum distance between this curve and that line is maximum profit. And people will pay you to tell them these things, right? People will pay you real cash money to be able to tell them how to make the most money. So there's a price between these two, which they'll make the maximum money. We're not going to do that today, but that's what's kind of cool about what we got going on. All right, that's the warm up. Fantastic. Let's talk about example 3 here. All right. Well, one of the little philosophies we use here is where this practice with others thing, if I'm going to give you an example, I want to give you a problem which is exactly like the example I'm giving you. So I want you to keep looking, when you're trying to solve this one here, I want you to keep looking at this one here to figure out, well, how did they do that? How did they do all this stuff? Look at their numbers, look what they did with their numbers, figure it out from there, okay? Let me. All right. So they're using a spreadsheet. The problem they're saying is use a spreadsheet to determine the break-even price for Picasso-based product. If you have a Chromebook, if you want right now, you can use this link right here in Google Classroom. Go to lesson number 32, Google Classroom. In there, there'll be in a document tab, a spreadsheet. Make your own copy. The spreadsheet will have these things here. If you don't have your Chromebook or you don't want to use your Chromebook and don't want to play with spreadsheets and don't want to learn how to do them, that's fine. We'll make this work. It's like extra. Like businesses will pay people to do things on spreadsheets. And if you can learn how to work on spreadsheets, you have a money making skill. All right. So if you don't want to learn it, that's fine. We'll just do it on paper. If you do want to learn it, there it is for you. All right. So we have to use a spreadsheet to determine the break-even price. Basically, we're doing on a spreadsheet what we just did on that front example. The expense is going to equal the revenue function. All right. So we're going to develop general and expense revenue equations. So the spreadsheet can calculate the break-even prices regardless of the situations. The expense function is E equals V times P plus F. When P equals the price, V equals the variable costs, and F equals the fixed costs. So this is how much it costs them per unit to produce. If they're producing lawnmowers, maybe it costs them $1,000 in materials for every lawnmower they make. So every lawnmower they make, they're losing money just in terms of expenses. And these are the fixed costs. These are the rent, the insurance, the labor, the machines, and the big presses and all the tools. All right. The revenue function is R, revenue, is equal to the A times P squared plus B times P, where P equals price again, and A and B are values specific to the particular situation of demand, essentially. Set the expense equation equal to the revenue equation. So to find the break-even points, E has to equal R. The expense function has to equal the revenue function. That will tell us where these two things are equal, and where they're equal are going to be the places where the break-even points happen. So the two equations get put in there, equal to each other. You then got to move everything to one side. It's usually easier to move everything to the side where the P squared is, or the X squared is. So they decide to move everything this way. So they're subtracting via P, they're subtracting F, they do all the math that needs to reconcile all that, and they get this final equation. So we now have a quadratic equation where A equals A, B equals V, and C equals F, negative F, right? So depending on your spreadsheet software, cell formulas can vary. The Picasso Paint's functions are E equals negative 3,500 times P plus 238,000, and R equals negative 500 times P squared plus 30,000. The values of V and F from the expense function are entered into cells B3 and B4. There's B3 and B4. So they entered these two numbers from their expense function. Oh, you couldn't see what I was doing. They entered the two numbers from their expense function, right? Negative 3,500 went into B3, B3, that's that cell B3, and 238,000, B4, B, column B, row 4, 238,000. And they're going to do the same thing again. They have their revenue function, right? The revenue function is negative 500 times P squared plus 30,000. They put that into cell B6, B6, and then they're going to break this apart into the coefficients. There's their negative 500, there's their 30,000. They need to solve this quadratic equation. There's their quadratic equation. They reconciled these two numbers, right? They added these two numbers up because when you get the set equal to 0, it's going to move over to the other side. So they added them up. That's how they got that number. And this became negative because they had to subtract it to get it all on one side of the equation. So then they identified what A, B, and C is, just like we did in the front. A equals negative 500, B equals 33,500, and C equals negative 238,000. And then you can get this spreadsheet to do the math for you, right? You can use a formula like this. Pardon me. You can use the formula in the spreadsheet to do all sorts of math for you, get the entire square root, right? There's square root functions in spreadsheets. You'll have to play around and figure, I might have got it partially set up for you. So take a look at if there's any clues, I usually set these things up pretty similar, but I don't remember how I did it. It was a long time ago when I planned this, 1 month ago or more. So anyway, we're now going to do what they did. All right, we're going to reproduce their spreadsheet on paper. Those of you doing it on your computer, that's fine. Here we go. So I think it's easier if we just kind of draw some lines. I would love to use a ruler, but I don't know if I have enough rulers to pass out to everybody. So I'll just draw it by hand. It's fine. We can't. All right, so we're going to do it just like they did it, right? They have their expense function here. So I'm going to put my expense function in. So what is my expense function? Oh, it's right there. So can I get this in the camera at the same time? I can't. Expense function right here. Expense function right here. Negative 1,000 P plus 10,000. I'm going to do whatever they did. I'm going to do it here in my paper. They broke it up into this. All right, so negative 1,000 goes here, and 10,000 goes here. You see how I'm copying just what they did? I'm doing that on mine. That was a comma. It's a comma, not a 9,000. All right, then they had their revenue function. Goes there. Oh, okay, let me put my revenue function. It's this right here. It's negative 1,000 P squared plus 8,500 P. And then they broke it up, right? They took 500. Okay, so I got to break it up too. There's my negative 10,000. There's my positive 8,500. Okay. So now I have to kind of give them the quadratic equation, figure this out. So let me just kind of do this up here. Negative 1,000 p plus 10,000 equals negative 1,000 p squared plus 8,500 p. All right. Well, I know I'm going to add 10,000 p to get rid of that, or 1,000 p, sorry. To get rid of it, I need to add 1,000 p. So I'm going to add 1,000 p there. I know I'm going to subtract 10,000 to move that this way. That cancels. That means I subtract 10,000 over here. What am I left with? I'm left with 0. 0 over here. That was intentional. Equals negative 1,000 p squared plus, calculator time, 8,000. Ooh, calculator has done. Oh, there it goes. 8,500 plus 1,000. P, right? Can't forget my variable. Minus 10,000. There's my quadratic, which goes in here. 1,000 p squared plus 9,500 p minus, or actually I like to do plus negative 10,000. You don't have to do it. It's the minus. It's fine. All right, I got to break all my things up. There's my A term. There's A, negative 1,000. Break it up my B term, 9,500. My C term, negative 10,000. I'm doing just what they did with their stuff here next to it, right? Now I got to find the break-even points. Boom. Now maybe okay, let's go start over again. Let's just start. I was going to say maybe we copy the thing we did before and enter new numbers, but maybe that confuses somebody. So alpha and his neighbor. All right, negative b, so negative parentheses 9,500. Close the parentheses. Let's start with my plus. My square root in there. Let's see. What do I need? I need b squared, right? B squared. So it's going to be parentheses. B, close parentheses, squared, minus 4ac. 4 times a, which is negative 1,000, times c, which is negative 10,000. Close the parentheses. Looking good. And then 2 times a, negative 1,000. I am not going to press enter here. That is your job. Once you press enter there once, you will then go up, and you will then highlight what you have, and then you'll go and she'll change this tip over here to a minus, sorry, so I said negative, minus sign, and you will do it again. And you will get 2 numbers. So that is going to be our box, all right? That is going to tell me if you are thinking versus only copying. We need thinkers, not copiers, okay? Copying is not learning, is not thinking. That's the bell. That is, and most of you, I think we did all of this yesterday. So now you can hit your independent